What is it?
Oh, so that's fluorescein.
Fluorescein, exactly.
Yes.
Which is science.
Eye drops.
And that's why you're here tonight, right? You're all
Yes.
here to learn science. I heard there's some comedy thing going on, but this is chemistry class. You're here for chemistry. So if we get interrupted, some people start performing this strange improv thing, we can just ignore it. Just ignore it. So get out your notebooks. You'll probably need a calculator at some point because chemistry and math are married,
Yes.
and they are in very, very tight relationship there. So notebooks. Where are your notebooks? Oh, one notebook. Good. We have two notebooks. Fantastic. Phone. What are you gonna text your friend while you're in chemistry class? True. Okay. We always got those young people.
Yeah.
They know technology. Well, yes, I'm Chemical Kim, and I'm here to teach you a little chemistry. And I was told I could not burn things in this room. Don't know why. I couldn't imagine us setting off an alarm. That would be harmful, right? That's learning. Oh, you have a question? Go ahead. Yes, that is radium. That is plutonium. So I did bring some radioluminescence to you tonight. And it is improv. So someone shout, all of you, just shout out something cold and I will improv that. Anything cold.
Dry ice.
Oh, what was that? Oh, someone said dry ice.
Dry ice.
Oh, I can totally improv dry ice.
thinking more like ice cream.
And can someone even go further to tell me exactly what dry ice is? What is this bubbly goodness? Right here.
I believe that it's like
What?
frozen carbon dioxide.
Frozen carbon dioxide, exactly. And what is the phase change that's taking place with this fantastic, bubbly, frozen carbon dioxide? Phase change. Sublimation. Well, we have some Smarties tonight. That's good.
Kind of looks like a
You
bomb.
have been studying. There's going to be a pop quiz later, so just be aware of that. Yes, absolutely. That is a process called sublimation. And someone near a smoke alarm, or those things you pull when there's a fire. Yeah, that's what it's called.
Yeah.
Well, why isn't someone pulling it? Don't you see the smoke? Aren't you worried?
No.
Why?
Water.
Why are you not worried? I would be worried. That is not the reason not to be worried. No, this is not smoke, right? What is it?
Water.
What is this?
Water vapor.
Water vapor, right? And water vapor is caused from the dry ice, and you should never, ever, ever put dry ice in your hand, right? Ever. That is extremely dangerous
Yes.
to ever handle this without a glove. Don't ever do that. Why? Why is it so dangerous to put dry ice in water?
Because it's extremely hard to freeze carbon dioxide, so it's really cold.
It's really cold. How cold is that? How cold is that? How cold is dry ice?
Minus 78 degrees. It's like a hookah.
You came from facial, right?
Yeah.
Don't worry. Yeah, this is water vapor. It's completely safe if I.
Inhale it. It'd be a little cold though.
Don't freeze your breath.
Whew. Okay. But seriously, this absolutely is cold. This is. Got your notebooks out, right? Negative. Okay, I'll give you a rough so that you can't write this down. And if I give you a really, difficult number to remember, you won't be able to pass your pop quiz. It's around negative 80 degrees Celsius,
Yep.
right? Negative 80 degrees Celsius. That's extremely cold. Around 110 degrees Fahrenheit for you non-science people. But that is very, very cold material. And it is just a matter of taking carbon dioxide, which if I filled this balloon up with carbon dioxide,
Absolutely.
So if you just push that together, just keep pushing it,
Oh, yeah.
hopefully you'll make some dry ice for us. Come on, make that dry ice.
What the heck?
Well, how far did you get in chemistry?
I have my degrees in accounting.
There you go, there you go.
Yeah.
But the idea is that if we condense that gas, that carbon dioxide, and we cool it down and it's condensing, we can get that dry ice. And that process of sublimation, going from a solid to a gas without, and this is my favorite little demonstration of it, without going through the liquid phase. So we skip through that liquid phase, right? Sublimation, solid to a gas, without going through liquid phase. Okay, improv number 2. Fantastic that all of you shouted out dry ice or carbon dioxide. Another improv. Name something colder than dry ice. Colder.
Liquid nitrogen.
Liquid nitrogen. Okay, I think I can transport liquid nitrogen. Okay, because liquid nitrogen is far colder than that dry ice. I'll do that by just showing you how it's going to freeze my hand. I'll just put my hand in it and show you that.
That's a bad burn.
Because demonstration
Really
with
bad.
science
Yep,
is
I've
good
done it.
learning, right? Losing your hand, that's part of the learning process. So,
You'll never forget.
you'll never forget, ever. I'm pouring it into a container that is surrounded by my friend Polly. Polystyrene's her last name. And polystyrene's a good insulator because this material, this liquid, is so cold that when it gets into a glove,
It's cold. That hurts.
it's so cold that the water vapor in the atmosphere, so everyone take a deep breath, blow. Oh, you just spit all over me. Gross. Gross. You just gave me a lot of water, right? There's a lot of water in our atmosphere. And the water vapor, because this is so cold, it will start to condense on the outside of that. So I keep it in my friend polystyrene, and that allows me to show you and let you see that liquid nitrogen really looks like water, doesn't it? And you want to taste it?
No thanks.
No?
No.
Temperature. Temperature.
Negative 130.
Close.
Pretty close.
Are you talking about Celsius or Fahrenheit?
Celsius.
Celsius.
Sorry, science dude.
In degrees Celsius, negative 195.8 degrees Celsius. Absolute zero, which is the coldest temperature that we can get material to. I mean, that's so extremely cold that we believe that atoms and molecules and particles stop moving at absolute zero. This is only about 77 degrees from that temperature. This, without a doubt, is probably the coldest material you'll probably ever see
Yep.
in your life. That is improv right there, right?
That's how you clean a floor.
But seriously. Oh yeah, clap for liquid
Yeah,
nitrogen.
yeah.
Yeah, clap for liquid nitrogen. Deserves your clapping for sure. I do need, I'm not joking though about the hand. I do need a volunteer. I don't want to lose my hand because I have 4 kids to support. And it's part of my profession. So I need a volunteer from, oh yeah, come on up. Come on up. You don't mind if I freeze your hand, right?
Sure, okay.
This glove got pretty frosty, but I'm not even gonna give it to you. Stand over here. I'm gonna wear the gloves. So you think I'm gonna give you a pair of gloves? Stand over here. Okay, so all I need, here, face the audience. Your name?
Commodore. Hello.
Hi, Commodore.
Commodore.
You like science?
Yes, I love science.
Even if it causes you to lose your hand.
Yes.
Yeah, dedication right there. Fantastic.
Committed.
So all I'm gonna have you do is just like stick your hand in that liquid.
One, that would probably freeze my blood and then I die. So I'm not really gonna do that. How about I stick like those flowers?
Okay, how about if you just stick your whole body in that liquid?
I would
And
die.
preserve your body, because this is, something that is utilized for
I will die as well.
for biological tissue, right?
Absolutely, that's right.
Absolutely. Okay. What about if we freeze some flowers?
Okay.
Okay, that sound good? Okay, I'm gonna have you step right in this position at the table. Okay. And the other reason is because, that improv comedy group that's coming in to perform, I just don't want them to slip on any flower petals. Okay. But this is a really cool demonstration with liquid nitrogen. It's my favorite. And what we're gonna do is freeze them, okay? But after they get frozen, I'm going to have you demonstrate to the lovely audience here tonight, because flowers are comprised mostly of water, right? And so by putting it into the liquid nitrogen, oh, science is so incredible. How can you not love science? Seriously,
It's like you're bubbling water.
that is smoking.
Smoking.
Okay, what I'm gonna have you do, because do you think they're now solid? Very, very solid?
I feel-
Icicles?
I feel like they're almost like icicles.
Okay, just take your hand and crush it. Go ahead. No, just squeeze it.
It's not
What are you doing to my flowers?
killing them, obviously.
Apparently.
Apparently, as it seems. I'm going to kill them.
What does it feel like? Describe to the crowd.
It feels like really, like if you have like icicles, but then they're mixed with ice cubes, and then they turned into flower petals. Really?
That is the best description I've ever heard. Pass it out. Pass it.
I'll pass it out.
Pass it out. Take the whole thing. Just take the whole thing. Enjoy your flowers. Let's give it a hand. Let's give it a
Yay!
And of course, my balloons are, you didn't do a very good job with that carbon dioxide balloon, right? But the nice thing about liquid nitrogen too is that it can condense gases, okay? It can get it down to, and actually I'm just gonna pour this right into my poly, leave myself a little bit more room. It can cool down the gas inside this balloon. And what will happen when a gas cools down? What will happen to it? It contracts, right? Looks like a heartbeat right now, but here you can see, it looks like I'm losing all the gas in the balloon. And that really is quite a fast process. If the gas in here is carbon dioxide, if it's oxygen, if it's water vapor, it's still there, okay? But I've condensed it because that liquid nitrogen is so incredibly cold. I hope you're not afraid if things pop, right?
Oh, there it
Because
goes.
it also solidified my balloon, the latex even more, kind of preventing it to be spaghetti-like, cooked spaghetti-like, and more like
You're gonna
uncooked
pop
spaghetti.
it right here.
But as it warms up, the gas, of course, is expanding back. So let's give it a hand to this For my last trick, because I know you came for Chemical Kim only, and so we can all leave after this one, is to have it compete with water, okay? Now, I already mentioned the temperature, and anyone back in this area, I'll let it be a group effort. What temperature is that liquid nitrogen in degrees Celsius?
195.
Negative 195.
What was that you said? Oh, we have some cheaters over here, some smart, Mr. Know-it-all. Okay, that's okay, it's okay to get help, but yeah, negative 195 degrees, 0.8 degrees Celsius, extremely cold. Okay, water at room temperature, degrees Celsius.
At room temperature?
Yeah.
20 something.
Yeah, 20 something, okay. So we're gonna do this competition. I want a show of hands. At the end of the competition, do you think liquid nitrogen will remain or water? Liquid nitrogen, raise your hand. Do you think liquid nitrogen will win the competition? Or do you think water will remain as a liquid?
Water,
Oh, you're
water,
just smarties.
water.
Here we go.
God, that's cool. All the dust.
And it's at this part of the show that Chemical Kim will
Disappears.
disappear. Thank you all, and I hope you really do enjoy the show tonight. And later, if you'd like for me to do an improv of any radio activity, just let me know. We got plutonium, polonium, radium, titanium. What's that?
He said polonium.
There you go.
Okay, do we go?